Today we'll be discussing Mapside Join technique. We'll be understanding how to do a join between two files. The same concept, it's a join between two files, but this time we want to understand how we can do a join using Mapside Join technique in MapReduce. Okay, here in the Mapside Join technique, as the name suggests, we are going to leverage the join technique at the mapper end. Okay, it is not at the reducer end. So let us try to do this actually, and let's try to understand how do we achieve that. Okay, so let me open the files and we'll basically understand again. As we follow the pattern, we'll take the problem statement and then we'll understand based on that problem statement. So I have a file transactions. Okay, and I also have another file which is users. Okay, so these are the two files I have, and I want to actually make use of these two files to do some joins using a different join technique. So here the first file is a transaction file where we basically have data about every user's transactions, what amount he spent, what product he bought, and which city he bought, everything. At the same time, there is another file called users file, which basically contains the customer's detail, like what is the user ID, what is the email address of that user, what is the name, all the personal information about that user. When he registers to that website, that user's profile will get created. So that data will be available in one file. Now what we need to do is very simple. The problem statement is very simple. I want to just join these two files and find out which user has done the maximum transactions along with his email ID. For example, or rather, even we don't want to do that because we have already seen that. So I would actually just suggest that let's do this way. I want to just find out, let's say, every record that we have in transaction. I want to find out which product that is bought, okay, for how much money, and what is the email address for that user. Okay, so as you can see, 400100 is the user ID. For that, the corresponding email address is this, user1@someplace.com. So likewise, you need to just print both the data in one file. That is what we want to do. Now you can actually come up with many use cases and you can solve it, and I have already shown you technique to do that. But right now we want to understand how we can leverage Mapside Join to do this processing. Okay. So let us do that. First of all, what is Mapside Join? So it is similar to the reduce side join, which basically talks about joining two files and extract some common information. But one more important point to Mapside Join is, in Mapside Join, you will actually do the join in mapper side. That means the mapper logic that you write, you need to take care of joining as well. Whereas in reduce side join, we are relying on the shuffle and sort framework. So for example, here if you notice these two, let's say, file which I want to process. First of all, can you tell me which file will be a very huge file in real time scenario? There is one file which contains transactions, one file which contains user details. So out of these two, what do you think, which file is a huge file? Transaction file, right? So the transaction file is basically a file which will contain lots of transactions by every user. Every user can do many transactions. Hence, that is definitely a file which will likely to grow and which will have so much data. Whereas user file is relatively not very huge. It will have fixed set of users and it will not really grow that in that kind of rate. So in this case, when we have these two files and we want to join these two files, and one of the file is very huge whereas another file is not so huge, that is a scenario where you can actually leverage a Mapside Join technique. Okay, for example, let's say, let me draw this architecture first. There is a transaction file, there is a users file. Alright. And we have basically, let's say, a job tracker and task tracker, or node manager, resource manager. You can call anything. Let's call it as resource manager for yarn and node manager, right? So this is your normal cluster. Now assume that transaction file, which is a very huge file, we have already stored it in SDFS. So it would be divided into two blocks, block 1 and 2. We are assuming that way. So let's assume that block 1 is available here, 2 is available here. Okay. And there is a users file also, which is a small file. So what we need to do is we need to basically leverage a Mapside Join technique, and to do that we need to basically load entire users file data into the memory, right, of a mapper task. So basically the crux here is one file, which is a huge file, you should put it in SDFS and let it be divided into normal different blocks as we understood earlier. But the smaller file will have to be transferred by the master to all the machines local file system, so that you can directly load entire smaller file into the memory of MapTask. So let me give you a little bit more details on that, how Mapside Join works. So what we do is, let's assume we have written a program, and resource manager will create, it will basically create application master, which will assign map task. So map task 1 and map task 2 are, let's say, allocated to these guys. Map task 1 and map task 2 . Okay, so NM means node manager, RM means resource manager. Okay, and we'll understand what they do later, not now. Okay, so job tracker will basically assign, let's say, this map task to the task tracker, and these map tasks will be running on a separate JVM here. Okay, and they are going to process all the block 1 data which is available in this file. Similarly, this guy will process all the block 2 data available here. Okay. Now the idea here is, we don't really want to process only one file, right? In our example, we have 2 files, and I want to join these 2 files. See, in the yesterday's example, we have actually created multiple mapper classes which are processing multiple files in SDFS. But in this case, I am going to load this entire users file data into the memory of this map task, okay, which is running in a separate JVM. So what job tracker does is, it basically takes this file. You have to tell him which file to be loaded into the memory. So job tracker will actually take this file and put it into the distributed cache of every task tracker machine. So here we are going to learn one more concept called distributed cache. Okay, distributed cache is an area in the local file system of every slave machine. Okay, let me just delete some of the stuff here. It has become a lot of cumbersome here. So yeah, this is, let's say, task tracker 1, this is task tracker 2, task tracker 3, task tracker 4. And let's assume that there is a local file system under which there is a distributed cache area under which you will store the file. There is it's actually not called DC, it's basically rather called cache only. There is a folder created as cache. And similarly, there is also a folder created as cache. Same way here also and here also. Okay, there is a cache folder created. So basically, this is an area in the local file system of these machines, which is always there. It is called distributed cache. Now, what is the advantage of using distributed cache? So whenever any map task wants to refer any third-party library or any particular data when it is processing any block, it can directly refer those files from this distributed cache into the memory, which means we just discussed that, let's say block 1 and 2 are stored here. So we are saying that, let's say block 1 is here, block 2 is here. Now job tracker has assigned, let's say map 1 to this machine and map 2 to this machine, because it wanted to process this big file, transaction file. Map 1 will be executed in the JVM of this machine. Map 2 will be executed in the JVM of this machine, which are going to, of course, process every record of this block one by one. And this is something that we already know, right? But here, as we discussed, that there is a users file which also I want to, join it with the transaction data. So what job tracker does, it will copy this entire users file. When the program starts execution, it copy that entire user file here. It will put this user file in the distributed cache folder, okay, in all these machines, okay. Basically, I mean all this machine in the sense, it will copy it every slave machines where the block is available, where this block is going to be processed. So that machines, the smaller file will get copied in the distributed cache area. Now what happens? The map task, when see, for every block, it is actually processing one record at a time. It calls map function on every record. When it processes one record, it actually reads entire user's data, put it in the memory of the map task, and then it joins it with the one record of the block. Similarly, it loads entire data of user file into memory of map2 task and then join it with the one record of this. So see what happens here. We are directly loading entire user's file from the distributed cache, from the local file system of this machine into the memory of map task. And it is just one time activity. You don't need to do it again and again, right? Because see, for example, this block, you will have, let's say, 1000 records. So I will call map function 1000 times, but loading entire users file into memory can happen only once. After that, you don't need to load it again and again for every 1000 records, right? So once you load it for all these 1000 records, you can use that data to join it. That's what happens, and that's why it is faster in terms of achieving this operation called join. Because one file, if you load everything in memory, you don't need to go to the disk again and again and read every record. So you minimize the disk IO. That is the reason when the small files are there, it should be put it in the distributed cache area so that it can be read into memory of map task. So by the way, mapper task can access only those files which are available in the distributed cache area. If any other location, if you put this file, you will not be able to read it from the map task. Only distributed cache is what it can access. Okay, so that's what it happens. And then after that, once it loads it, it will basically process every record, and that's how it does the join. Okay, so this is what we call it as a Mapside Join technique, where it uses a distributed cache area of MapReduce, where it can load everything into memory and then process the data in a faster manner. Okay, so basically we are going to write the logic where we do the join in mapper class only. But I just wanted to explain you what happens behind the scenes. Okay, and by the way, putting all the everything in this cache file, and then this cache file can be directly accessible to mapper. So there are APIs available through which we can directly read those data from memory, from the distributed cache area to the map task memory. So you don't need to really do a lot of programming here. Of course, there are some programs, some logic you need to write, but not too many lines of code. All right, good. So let's go ahead and start writing a program. Okay. So I will create a new class and we'll write a program here. So here, first let me write a driver code today. I will copy paste the driver code from some other class. I want to write a driver code because I want to show you how to load a file into distributed cache first. Here in this example, we don't need a reducer if you observe, because I just want to find out for every record what is the product and amount and a corresponding email address. That's what I want to display. So there is no reducer required. You are not doing any aggregation operation, right? So I'll be also showing you a technique where how do you make sure you don't use a reducer. So number of reduced tasks has to be set as 0. Otherwise it will use a reducer. Okay. Mapper class have to be some name. Just say map join mapper. Okay, fine. Now let us go ahead and write the. I'll first create a template class. Okay. So what I need to do now is, see, I have just created a template class so that we'll not get any error. Now what we need to do is I need to basically set the, I need to first copy this file, okay, into the distributed cache. So there is a API available called distributed cache dot add cache file. Okay. So initially the small file you will load it in SDFS, because from there only job tracker pick up and send it to the distributed cache of every machine. Here the small file you have to first load it in SDFS somewhere. So job tracker will read it from there, because job tracker can access only the SDFS data, right? So it will pick up that file and then push it to the distributed cache of every machine. Okay. So this is what we need to do. We are saying distributed cache.add cache file configuration. Okay. So this is the line which basically talks about, I mean, it informs job tracker that I have a small file available in this particular location in SDFS. Can you please copy this file in the distributed cache of every machine, right? That is what you are trying to say here. Okay, that is what this file means. So we just do this. We are setting number of reduced tasks as 0. So we are good with the driver code. Now no more changes are required. Now let us start writing the mapper code. Okay, and so job.configuration will have to be passed through which it access the job configuration and understands that for this particular job I am going to pass this. So it internally uses that configuration object basically. So it needs to be passed. It's an API. Okay. Now we are going to write a mapper class which will basically process this big file, which is a transaction file, correct? So that guy, the transaction file, by the way, will have input key, which is byte offset, and value, which is the entire record. And the output key is the user ID and the value is whatever value you want to give. It could be, I mean, we are, let's say, saying that 100 amount, product is exercise and fitness, and email address. Email, I'm getting it from the smaller file. So let's try to understand how do we get this. So the key will be iterable, value is the text object, right? So that's it. Now let us create this object first. Out key. Okay. Now there is one more important concept that I'm going to cover as part of this program, which is, if you notice here, when the job tracker picks up this small file, once you execute this statement in the driver code that I want to copy this small file in distributed cache, just by adding this one line, job tracker, when it executes this program, it copies this file into the every distributed cache folder of these machines, each slave machine. When it does that, and after that in the mapper code, as I discussed, we will have to load this entire smaller file data into memory, correct? So that we can join it with the each block records. Now, if a block has 1000 record, I'll be calling map function 1000 times, but that doesn't mean that I should load this file every time again and again, right? 1000 times. I should load it only once. So when you have such kind of scenario where you want to do some pre-processing before you want your map function to start executed for every record, okay? So before every record of this block, if you want some kind of pre-processing to be done, which should be executed only once for entire block, then you should call a method called setup. There is a method available. You need to override it as setup method. Okay, the setup method will have a context object, and inside a setup method I'm going to do all these things. So I'm going to load the data from memory and then process it. So setup method, what I do is I'll have a context object passed, and then I'll be basically loading the entire smaller file into the memory. How do I do it? So I'll do it something like this. I have to basically write the entire logic here. So in the setup method, I will first read all the files available in distributed cache. Remember one thing, in the distributed cache area, you may have lot of files available. It's not that only one file which you have copied as a small file can be available. Other programs would have also copied some small other files. So I need to first get all the list of files and then find out which file I'm interested to read. So that's why there is a API which helps me do that. I will basically say distributed cache dot get local cache files. Okay. This guy will give me the files. And then what I will do is I'll iterate through this. I'll let's say for each file in the files array, I will check if file dot okay, or you can directly say equals also works fine. If this file name is users.txt which I want to read, fair enough. I'll go ahead and read that file. So I'll be basically doing this. I'll do this. I mean, here you need to just write a logic to read the file from the disk, and this is called file input output stream that we basically normally read. I mean, it's if you have done Java IO programming, file IO programming, you will know how to read a file from the disk. Okay, so I'll be copy pasting some of the logic here, which will be helpful to you to understand that. So once I know that this is my file which I want to read, actually, which is a user's file, what I will do is I will basically open a file reader which talks to that file. Then I will open a buffer reader on top of that, and I will read. It's like I'm creating a stream by connecting to that file object, and then reading every character of that file one by one. I mean, every line of that file one by one. As you can see that I'm actually reading the line, and then I'll be I mean, how do I iterate it? So I'll just do this. You can just do this. Line is equals to reader. That's it. Basically, while line not equal to null, I'll keep on reading the new lines. Okay, and in between I will also process that line. So once file will complete, say for example here in this file, I will have those lines. This is the file I'm reading, by the way, small file. So actually I'm reading every record one by one till the record, till I'm not finding any line in the file. So every line I'm reading, and then I have to do some pre-processing here, and then I'm moving on to the next line. So same thing happens here with this code. Okay, so in between, now once I get this line, one line at a time, I need to split that line. So what I will do, I'll just say line dot split based on comma. I'll get columns. Okay, and now see what I'm trying to extract here. I'm trying to extract the email address. And email address for what? For the given user ID. So you can understand that still if I want to join both of this file, I need to have one common column, which is a user ID in our case. So based on that, I'm going to join the data, right? So that user ID will have to be a crucial part. So it is actually a common column. So I'll just say user ID is a common column, and then what I'll be doing is I'll just say columns of, let's say, in the smaller file, 0 is like first column is a user ID column. So I'll be doing this column 0, and I'll be assigning it to string name, sorry, user ID. And once I have the user ID, I will also assign it to, I mean, that is one user ID, and there is an email address. So I will also take email address, which is columns of 1. So these are the two columns I will be needing. Now, when we say that we want to read this smaller file into memory, what exactly we should do? We are reading it right now, we know that, but I have to store this data, right? I have to keep this data somewhere in the memory. When I say I'm keeping it here in the memory, I need some data structure which can hold that data, right? Okay, and most of you know in programming that if you want to hold any data which contains keys and values, you should actually have a data structure which is called hash map. Excellent. Yes, Rammohan, that's right. Yes, Umesh, that's right. So you can use a hash map. So let me create a map object, okay, which contains string. It's not exactly string. This should be the integer actually, because it's a user ID, right? And then I'll have string. I'll just say users data. User data is equals to new. Okay, and after that, once I create this, I can use that map here. By the way, here I should directly convert it into integer. And I'll just copy the data. User data dot put. In the map, when you want to put a key and value, you'll just say put user ID and value is email. That's it, done. Okay. So as in when I'm reading one line, I'm basically, as in when I'm reading the line, I'm actually basically parsing that line. For example, here if you see, this is one line which I am reading from the smaller file. I'll be parsing that line, get the user ID and the email address, and I have to hold that data somewhere in memory. For that, I'm using a hash map data structure which can hold data in the form of key and value. So I'm actually putting user ID as a key and the value as an email address. That's it. For every line, I'm converting into key value and then I'm putting it into the user's data hash map. That's it. So that's how I'm going to copy the entire user file into this hash map. That is my first job. So what I have done by now, by completion of this method, I should have read the entire smaller file, which is a user file from the distributed cache into the memory of map task. And I would have formed a hash map object, which is user's data. Okay. Now in the map method, what we'll be doing is we'll be again processing every line and then we are trying to convert it into the key and value. So it's a normal way. This map function is getting called for what? It is getting called for this bigger file, the block 1 and 2, which is for transaction file. So you will be saying this. So value. Okay. Now I'll be taking a key which is user ID, columns of, in this big file I'll have third column is a user ID. And this should be the integer. Excuse me. Now this is where we should be doing a join. Okay, now once you have this user ID that you have read from this bigger file, you have to get the corresponding email address from the users data which you have loaded in the hash map. So what you can do is you can do something like this. I'll say user data as a map object dot get of user ID. Okay, so whenever you want to, if it's like this, right? If I have a map which contains key and value, if I have, let's say, user ID 100 and the value email address is email 1, value 200 email 2, value 300 email 3, right? Now if I say in this map object, if I say map.get of key, so if I pass map.get of 100, then what do I get? I'll get corresponding email address, corresponding value, which is email 1. If I pass 200, I'll get the corresponding email address for that key. If I pass, let's say 500, which is not there in the map, what should I get? There is no key available here, so it will give me null as a value. Okay. So basically, this is where I'll be doing the joining. So I'll be actually doing something like this. String email is equals to this. That's it. This line will do the join between transaction as well as user file. Okay. This is called Mapside Join. This is where you are doing a join and get the corresponding email address. Apart from that, you can actually get, let's say product, which product he bought. So that you can get it from the transaction file itself. This is the one, the fourth column. So that is what you will be putting here. That's it. And then I'll be basically, I have to also create, by the way, I already have created output value object. So I'll just do this output value dot set. I'll say email address is email and product bought is product. Okay, and then I'll say this context dot write key. What is a key? Key, let it be the same because we are not changing the key, and the value is output value. I think this is not this key. I'm sorry. This is the key you have to create. So out key dot set the user ID. I'm taking user ID as a key, so I'll write it here as a user ID output key. Okay, that's it. That completes my mapper code as well. Okay, there is one warning which says reader object is never closed. So ideally, once your input output stream object is done, you should close it actually, so that it will release the resources. That is a good practice. You should do it. Otherwise, there will be memory leak actually. Okay, so this completes my map join program. Okay, and I have explained you a couple of things here. One is how to use distributed cache in the map join and how to do the map join. What is the use of setup method? Setup method, you can use it not only for map join but for some other purpose also, right? Whenever, let's say, you want to call some logic before entire block, before you start processing every record of that block, you should write that logic in a setup method. And another thing which we have seen is when there could be a MapReduce job which doesn't have any reducer, right? It doesn't have any shuffle and sort and reducer executed, only map. So which means the output that this map tasks are going to write, the output file which is going to be created, it will not be created in the local file system of this machine. Normally, in a MapReduce program, we have learned that it will be created in a local file system, but when you don't have a reducer, this file will be directly loaded into the SDFS path. Okay, and the name of the file will be part M000 and part M001. Okay, it's M, not R, because it's an output of map task. So whenever you see any output file name with this, you should understand that no reducer has run for that program. And you can make sure no reducer run by doing this way. Set number of reduced tasks as 0. Okay.